Hello everyone. Question 9 says, study the opposite circuit and calculate. There's no need for this E. Anyway, first they need the equivalent capacitance. So we notice here that C2 and C3 are connected in parallel. Let me divide this area. Okay, so I can find the C in parallel is actually the sum of them is going to be 60 plus 20, okay, which is 80 microfarad. Okay, now this here, the C parallel with the C1, they are in series, which means I can find the C total. Now here I will write the formula. It's going to be 1 over C1 plus 1 over C parallel to the power -1, okay, which will give me the C total equals to 1 over C1 is 12 plus 1 over 80, which is the C parallel, -1. I get the answer. C total will be 10.43 microfarad, and here I change to farad, multiple 10 to the power negative, this is 10 by the way, -6 farad. Okay, you can change from the beginning, from like here and here, okay, but I guess it will be easier if you left the changing to the end. Okay, so this is part A. In part B they want the total charge, the total charge of the battery right here that goes out of the battery. We know from before that Q equals capacitance multiple voltage. Of course here is going to be the total capacitance because they need total charge, and here the voltage of the battery, let's call it V total also, okay, which will give me 10.34 or 43, I'm sorry, 43, wait, let me erase, okay, to make it clearer. So 10.43 multiple 10 to the power -6 multiplied by the V total, it is 6 volts, and this will give me that total charge is going to be 6.26 multiple 10 to the power -5 coulomb. Okay, remember guys, if the C is after a number, this C, it's after a number, so it is a unit, it's a coulomb. Okay, not to be confused with the capacitance. Now they want VAB and VBD, so they need VAB, it means the voltage right here between the C1 or in the C1. Okay, pay attention that C1 is connected in series with the battery, right? It's in series, it means it will have the same charge as the battery, as the charge we found before right here. Okay, so to find the VAB, we know the formula is going to be Q over C. So which Q, as we agreed, it's the Q total that we found before, and which C, it is C1, right? So it's going to be 6.26 multiple 10 to the power -5 over the C1 is 12 multiple 10 to the power -6, and this will give me 5.22 volt. Okay, this is the voltage VAB. Good. Now they want VBD. I will do it right here. I'll change the color. Please pay attention to this idea here. The voltage in the battery, it will split or be divided into V1, I'll name this one V1 or VAB, and the V here in the parallel combination, because the parallel combination, which is here the CP and the C1 are connected in series, so the voltage will split between them. So I can say V total is actually V parallel plus the V1. Okay, V parallel is actually the VBD. So this means I bring this to the other side, is going to be V minus V1, okay, which is VAB, equals V parallel, which I will name it as they asked for it, BD. Okay, this will give me 6 minus 5.22. Okay, this is VBD, and this will give me, I do the subtraction is going to be 0.78 volt. So the voltage up here, it is 0.78. Right here with the V1, it is actually 5.22. Of course, each one is volt. Okay, I hope it's clear. Do I have? Oh, I still have. Okay, good. Now the charge on each capacitor. Good. The charge on each capacitor. Okay, let me erase some of these here because I need to write here. Okay. Good. The charge on each capacitor. Let's first talk about the charge on capacitor C1. We just agreed it is connected in series with the battery. It means it will have the same charge as you can see right here. So I can say that Q1 is actually the same as Q, which is 6.26 multiple 10 to the power -5. Okay, so we found the charge on the first one. Now I need the charge in the C2 and the charge in the C3. We know that charge equals C multiple V. Okay, let me wait. Okay, here I will write down here. So the Q2 is actually C2 multiple V. Which V, guys? It's the voltage in the parallel combination between B and D, okay? D and B. So basically the V2 and V3 are the same. Let me write it up here. The V2 equals to V3, which equals to the VBD, which we found before. Why is that? Because I'm sure you know they are in parallel. Okay, so it's going to be C2, how much it was? It was 60. Okay, 60 multiple 10 to the power -6 multiple the V, it is 0.78. 0.78. So it's going to be the value. Wait. It is, yes, I got it before. It is 4.68 multiple 10 to the power -5. Okay, please check the numbers after me. Maybe I made like a mistake or something. This is the Q in the capacitor 2. Of course, remember the unit is coulomb. Now the Q in capacitor 3, okay, is going to be capacitance 3 multiple the V. How much was it? It was 20. Okay, good. So it is 20 multiple 10 to the power -6 multiple the voltage, which is 0.78. I will get 156, I'm sorry, multiple 10 to the power -5. Let me make sure of this number. I just want to make sure of this number because it looks weird a little bit. 20 multiple 10 to the power -6 multiplied by 0.78, it will be it's 1.56 1.56 multiple 10 to the power -5. Of course, it's coulomb. Okay. Let me check. Do I have anything? Oh, yes, we have. Now they say if the distance between plates of C1 is halved, what will happen to the total capacitance and the total potential difference? Okay. Now, let me first here write. I will write the formula. C1 is actually epsilon A over D1. Okay, this is before the changing. After the changing is going to be C1 prime is going to be epsilon A over D prime. D prime, it is half the normal D, so it's going to be epsilon A over half D. This will give me 2 multiple epsilon A over D, which will give me, I will write from the beginning, C1 prime equals to double the C1. Okay, so the C1 will double after we halve the distance between them. Okay, so the total charge will increase, right? The total charge will increase. I will find the total charge. Okay, the total charge will be C total is going to be 1 over the parallel combination, it is 80, plus 1 over, instead of 12 it became 24, right? So the total is now 18, of course here to the power negative 1, 18.46 multiple 10 to the power negative 6 farad. It increased. Remember, how much was it? It was where yes, it was 10.43. Now it is 18.46. So basically the total capacitor increased. It increased. Now they say also what will happen to the total potential difference. Here the changing of the capacitance will change actually the charge, but basically we are using the same battery. We didn't change the battery, so the potential difference will stay the same. The total potential difference will not be affected because we are using the same battery, so potential difference doesn't change. Basically we are using the same battery or power supply. What will change also with the capacitance is actually the charge. Okay, I hope it's clear. It's a long question actually. If you have any note or question or thing you want to say, please leave it in the comments below. Have a nice day. Bye bye.